All right, so progress unit 6, progress check number 17. I think it's a little more straightforward than 16D especially was tough. So I'm going to go relatively quickly here, and all we're doing here for part A is evaluating the integral from 0 to 7 of f prime of x dx. Well, they gave us this graph, and this is the graph of f prime of x, so what we're doing is we're evaluating this from 0 to 7. So we're just calculating the area from left to right, 2 minus 7 plus 3 plus 1, because the minus 7 is, we're going from left to right and it's below the x-axis. So 2 minus 7 plus 3 plus 1 is negative 7. There's our answer. Okay. Part B is a little more difficult, but not too bad. They give us the initial value of f of 4 equals 10. They want to find the absolute max. They want to find the absolute max and min. Once we hear absolute max and min, we need to include endpoints. All right. And we write this function as f of x equals my initial value, which is f of 4, plus the integral. Now, it's not going from 0. We're going from 4 to x. That means sometimes we could be going to the right, and sometimes we could be going to the left. To the right is positive. So we're going from 4 now. So sometimes we're going from the right, and sometimes we're moving to the left. The left switches the signs. So where this was originally negative 7, it now becomes positive 7 because it's a double negative. Okay, so the absolute maximum. So we have to find out where the possible absolute maximum and minimums are. That is where f prime of x equals 0. And that is where our graph crosses or touches the x-axis at x equals 1, x equals 4, and x equals 6. We are also including, because we're talking about extreme value, the end values. X is 7 and x is 0. Okay? Okay. So, what we're really doing here is we're evaluating. We're going to add 10 to everything. So it's going to be 10, which is our starting value. So this is our f of 4. I'm going to add the integral. We're going to add the integral from 4 to x f of t dt. So that's our process. Okay, let me change markers, get a little bit sharper marker. All right, so f of 4 is always going to be our value. And we're going to integrate from 4 to 0. That's going to be our first one, f of t dt. We're going to integrate from 4 to 1, f of t dt. We're going to integrate, I'll just keep going with the squiggle. We're going to integrate from 4 to 4, f of t dt. And we're going to integrate from 4 to, we're not even going to do 6, because 6 actually bounces off the axis, so it's 0, but it's not a max or min, so it goes from positive to positive. So we're going to go 4 to 7 of f of t dt. Okay, so those are our 4 things we're going to do. 4 to 0, 4 to 1, 4 to 4, 4 to 7. All of which we're going to add 10 to find out our max and min. So 4 to 0 is, we go from 4 to the left to 0. Well, we have positive 7, because remember, to the left, and it's below the x-axis, so we have 7, and we have negative 2, because it's above the x-axis, so we have 7 minus 2, so 10 plus 5, or 15. So 4 to 0 is 15. Remember, we're adding the 10 to every one of these, okay? 4 to 1, exact same concept, but instead of going all the way to 0, we stop at 1. Therefore, instead of subtracting 2, we're simply doing 10 plus 7. So 4 to 1 gives us 17. 4 to 4, any integral from where the top and the bottom boundary are the same is 0. Therefore, this becomes 10 plus 0, or 10. Remember, we're adding 10 to every one of these because that is f of 4. And lastly, we go 4 to 7. Remember, we discounted the 6 because it's not a max or min, because it doesn't change sign there. So we're going 10 plus 3 plus 1, or 14. So now our absolute minimum occurs at t equals 4, and that is equal to 10, and our absolute maximum occurs at t equals 1, and that is 17. Okay, part C. They just want us to do the integral from g to x. They gave us g to x to be 5 minus x squared. Therefore, we're simply doing the fundamental theorem without the definite integrals, and this becomes 5x minus 1/3 x cubed, all plus c, and that's our answer. Don't overthink it. Okay, enjoy. All right, folks, so part D is a little involved, but not too bad. All right, we have the integral of 1 to 2, the integral of from 1 to 2 of x f prime of gx dx. Seems daunting to begin with, but if we recognize the fact that this is a chain rule inside of an integral, then we realize we must use u substitution. So because we have a chain rule inside of an integral, in other words, just a composition of functions, we need to use u substitution. So we do u equals g of x, and then we have, u equals 5 minus x squared, as we've done a million times. Take the derivative. Du equals negative 2x dx. We want it to be x dx, therefore we do negative 1/2. Okay, so x dx we divide by negative 1/2, which means we can rewrite this integral as negative 1/2 on the outside, f prime of u du on the inside, and then 4 to 1 is my boundaries. Remember, with u substitution, we need to take our boundary, in this case 1, plug it into here, and get 5 minus 1, so that becomes 4. And take our top boundary 2 and do 5 minus 2 squared, or 5 minus 4, to get 1. So we've changed our boundaries with the u substitution. Now from here, remember, we're only talking about evaluating this graph, so we can do one of two ways. We can switch the 4 and 1 to 1 and 4, and make the the negative 1/2 positive, all right? Or, and the f prime of u du stays the same, or we can leave it alone and evaluate the 4 to 1 f prime of u du as it is. Now, if we're doing this algebraically, in other words, where we have an actual function, we can do it differently, but now we're just reading from a graph. So now it's simply a matter of either going from 1 to 4, right, which is going to be negative 7, okay? So 1 to 4 becomes negative 7 times positive 1/2 is negative 7/2, okay? Or, like I said, we can go from 4 to 1, which is 4 to 1 to the left, is this negative 7 becomes positive 7, therefore this becomes negative 1/2 times 7, or negative 7/2. Both answers are going to get it the same way, but at this point we're using our graph to evaluate, okay?